you can
Hello
see my screen,
everyone,
right?
welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Felipe who has completed the course ROS 2 Basics using Python, and you'll be giving a presentation on what he's managed to do. So you first demonstrate uh, his code base on the real robot, and then we'll get into the details about how he managed to do his project. So I will now hand over the platform to him so he can begin his presentation. Okay, so over to you, Felipe. Whenever you're ready.
Yeah. Just thank you for the introduction, and let me. That is time to connect to the robot. So
All right.
just give me a moment. Can you see my screen, right?
Yes, I can see it nicely.
Okay, that's perfect.
All right.
Okay, let me see if it's connected. Okay. Oh no, gamepad connected. Okay. Okay, basically here I'm in the robot. So okay, what can I say? I have this project that it was created as a requirement for the course that we were working with the Rust basics in Python.
Mm-hmm.
So I'm gonna run it, but basically just as a brief introduction, I'm using in the Rust 2 workspace. I creating like this wallflower package that is using a couple of actions and services that I include in the custom interface
Mm-hmm.
set of code. So just let me in the terminal.
Can you enlarge your code editor a little bit so we can see it
Yeah,
within the
sure.
screen?
Yeah, sure. Just let me just let me open my terminal to run. So I want to be sure that everything is correct.
Okay.
Yep. Um, the source. Okay. Let's see. Where's the robot? Ah, okay. Where's the terminal here? Okay. Okay. And I'm gonna run. So everything is packaged in this. Everything is packaged in this like launch. There is the main launch. So basically, so it's very interesting of the course that we were working with the construction AI is that they have this opportunity to work with topic service and actions. So just as a brief introduction to, uh, we're working with a topic related with the information of the laser scan and moving moving the robot with the twist node, the service that we're using for the wall finder, and the action that is using the odometry that that the well, that you have to take the information and to set the path. So basically, I'm gonna run the algorithm. So what the algorithm is doing is that it's detecting what is the nearest wall that we have or that the robot is facing,
Mm-hmm.
and according to that distance is gonna, depending if the distance is like big enough or short enough, he's
Mm-hmm.
gonna detect initially where's the nearest wall that we have. I can show you even in the code.
Mm-hmm.
um it's gonna decide where is the nearest wall, and according to that it's gonna follow that wall. We set like a distance to be followed that needs to be between zero point 0.2 meters and zero point 0.3 meters, so it's 20 and 30 centimeters.
Okay.
So according to that, it's gonna make that following. If it's like kind of far to the wall, I can show you in the code. Let me show you here in the code. So I have basically as an explanation. So we have this algorithm that is the wall following. So in the wall following, we are including the information of the laser scan. So this laser scan is the like the code that is gonna give us the information of the sensors that they are reading, and well, we're setting some parameters and using the service that is the wall following. So basically here, this is the action or the control logic that we are using. So if the distance to the front wall is less than 50 centimeters, the robot is going to turn left to avoid like a collision in the front.
All right. Sorry,
According
Philip.
to that, yeah.
Have you run your code on the real robot yet? You haven't, right?
Oh,
Yes, because I think you will run out of time if you don't do it now. So
okay.
you have to show us the robot doing what you're explaining right now, so we can see.
Okay. Yes. So yeah, let me know. Yes, I'm launching there.
I think you're already connected, so you're supposed to run your launch file that can do the wall finder, and then you get to have the robot do the wall following action that
Oh
we were
yeah,
speaking about.
I run it like now I'm here in the terminal because I just need to launch the main launch that I
Okay,
have.
okay. So let's do that and see.
Yeah.
So let's see what the robot is doing.
Yeah, so technically it says that it's using the server of like the wall find, and it's needs to detect like it's gonna detect like the wall that is
Yes,
like
but
close
then
to it.
it has to do that on the real robot, right? You have to see the robot spinning around to find the wall. Right now, on the
Yeah,
picture there, we do not see that happening.
yeah. I don't know explicitly what because technically it says that it needs to be making the rotation.
Okay. All right. Let's give it some time. Let's get into the code, and you will keep on explaining. Then we'll try a little bit later before we are out of our 20 minutes window.
Okay, sure. So let's give it some time. So yeah, as I was explaining to you, basically this is like the control logic that we're using. So we're getting the information of the distance initially to the front of the wall. If it's less than 50 centimeters, then it's gonna make a turn left to avoid like a collision in front. Then it's gonna check like the distance to the wall. If it's like a big distance, it's gonna basically just increase like the linear and the velocity, like the linear and the angular velocity to approach to the wall. And if it's too close, basically as well it's gonna move away to the wall to avoid the velocity. At the end, it's gonna just gonna like advance forward if it's like between the ideal values that we're having.
All right.
Basically here we are processing the information of the laser scan. So basically to have like the bright red detection to make it like a 90 degrees angle, we are considering here like the angle that we are obtaining. And well, later we are using the information of the odometry that is part of like the actions that we are including to basically have like that information to make the bot. Additional to that, okay, so we have this wall follower package, and we have this custom interface that have like the action that is we have the service that is defined code that basically just return like a boolean variable that is according to the if the robot like go to the or find the wall that is the nearest one or is not, it's gonna return like a true or false. And the action that basically is gonna just give like the list of information regarding with the bot that we're using. So it's gonna return us that information. So we're calling this custom interface in all of the codes that we were using. The custom interface, the service, and the actions. There is this wall finder that basically as well is using the custom interface service that we create. It's creating like the service server that have like the information like the wall that is being found, and again it's gonna make like a publication, a subscription to the information regarding with the CMD build for the moving of the robot and the laser scan that we are considering. Here, the algorithm basically identify what is the closest wall. So basically, we are checking like the information of the front laser, and according to that, it's gonna give us like which one is or to find like the wall that is close. It's gonna make like a rotation according to where it's located initially, like in the robot. Okay. Basically, it's gonna like like the way that the compass is working is like it's gonna rotate to face the closed wall. So it's gonna initially like make like a rotation according to the first position, and it's gonna identify like which one is the closest one. Then it's gonna move to the robot until like 30 centimeters from the wall. That is actually was part of like the requirement, and at the same time like the distance that we are having that between 20 centimeters and 30 centimeters. So basically we're telling to the robot like, okay, trying to go less than 30 centimeters away to the wall that is already there. That is like at the beginning of the algorithm, just to mention everything. So yeah, according to that, we rotate the robot to have to the wall on its right side. Basically, the idea to the wall following is that we expect that the robot move and the wall is always like in the right side to have like information of like the path that we're having. And at the end, we to have like the service working, we return the service message with truth. That is basically just like the definition of the service that we were using. Okay, just maybe as a comment of this part is like because we were using like callbacks that needs to be and like all in the robot, we basically call this multi-thread to have like all information at the same time in the robot. Okay. As final as an action that records like the information, we are using this action server that is the Odom record. So basically, this Odom record take all the information of the positions and the sensor of the robot, and we are basically just like saving all that information to make like the path for the robot that needs to be complete. So basically, we're creating here the action server that is called the record Odom, that is subscriber to the odometry, that is the sensor that is going to give us the information of like the walls. So basically in this action, what we are doing is saving the path from the initial point, starting from an initial point, and that is gonna save all the information in this event of like the current point that the robot is having at every second. So we're having this at every second. That's the reason of the time sleep. The distance, well, we're showing like the distance to the last point and the distance to the last distance feedback, because we're using like a feedback system that is basically using all the total distance that we are obtaining from the odometer. And this is just to create like a path. We have here later uh, a function that detects when the robot completes like a lap. So basically, what it does is like to check if the distance to the start is already made like a whole lap in the environment. So according to that, it's gonna just give us that information, and it's gonna be like part of like the goal at the end. If like the robot like complete like a path there, it's gonna record that information. Yeah, just as a final detail, this is the callback that we're using to get the position of the of X and Y in every segment of the robot, and at the end we basically have this this check to finish like a ladder. And yeah, we're using like the same motivator that we're using for all the service action and the main function with the topic. So yeah, that's basically, well, just like as an additional um, details of the code. Yeah, I create like the package that I mentioned to you. The package of custom interface has like the autumn record and define wall. Okay, just like the configuration of the CMake list and the package, and the wall follower that is a pure Python package that basically has all the algorithms here in the wall follower folder.
All right, I see.
Um,
You have got 3 more minutes, so I would rather suggest you try running your code on your real robot, on the real robot again, before we're out
yeah,
of
sure.
time. So
Yeah, sure. Let me.
try putting it in a different place and then running it using the
Yeah,
joystick
look
to
at
put
this.
it in a different place.
But look at. I don't know if you could see at the beginning. I connected. That I should I I make the layout.
Yeah, that's what I was hoping you would be able to do with a joystick. Um, I see it's not moving.
Yeah, moving with the joystick. Look at.
All right, I see. You're still connected, right? I see your days. It's still showing that it's
Yeah,
connected.
I'm connected. Look at here.
All right, I see. Okay, let's get into the questions for now. Can you go back to your code base? There are some things I want to look at
Yeah,
and
sure.
ask you about. So you mentioned creating custom interfaces for the service
Yeah,
and the actions. Yeah, can you explain why you felt the need to do that? Why did you feel like you had to implement custom interfaces?
okay, basically, when I started with I was following like the I don't know, like the notebooks that you guys have like for the course. So
Mm-hmm.
when I started with the topic, that it was like the first part, I
Yes.
was just using the wall follower package,
Mm-hmm.
and just the topic for the
Yes.
wall following. It
Yes.
was just in the wall follower. Then when I include like the service part, that it was to find the wall, to make like the find wall algorithm.
Mm.
When I included in the same package as the I included in the same package as the wall following
Mm-hmm.
algorithm, so in the wall follower. But honestly, I was having like a lot of like errors when I included there. I
Mm-hmm.
don't know if it was because of the type of compilation or something like that. But when I just include like, the server in the like the service in the same package, I included like for example here, instead of like have like custom interface that SRV, I was just
Mm-hmm.
calling
I get that.
the same.
Yeah, I
Yeah.
get that. I want to find out if you do understand why you need to have those implemented, right? Like, what are they doing within your source code or within the course of your code working on the robot? What is the significance of those interfaces? That's what I want to understand.
Oh yeah. So then I started like to check that maybe it can be like a misinterpretation when I was using like the service and action in the same package the way to be called. That was maybe the reason I was facing those errors when I was starting to program that part. So like after maybe I asked my instructor and some partners, they suggest me that maybe a best way and a good practice to have like the information driven is in the course. So I split like the service and actions in order to make it simple to be called and to make it efficient, even if we are working with like the threads. So uh, even I can split them in like just like a service package and an action package. But then I see that I can pack them in like the custom interface, because like the custom interface is not like a pure Python package. So
Okay.
that's like an advantage when we're using like some information that have the laser of that have the odometry, that maybe it's gonna be easy according to the package or to the sensor or to the data that we need to access for. So when I was reading, that was like the suggestion, and when I check like some I don't know like tutorials or something like that,
Mm-hmm.
I saw it. So I created like this custom interface that it was going. The idea is to include like all the additional parameters, and with all the additional parameters, it was going to be easy to be called. So when I created and I
All
called
right.
it then the service, it worked. So I was like, okay, that was the best way to do it and good practice.
All right. I see. I see. Okay. Can you also give me an explanation of why did you choose to use a service for the wall finder? What's the why a service? Why not just a topic or an action, for example?
Okay, yeah. Because at the beginning, like if I just have like the topic, I needed at the beginning to move to the robot close enough to a wall to start like the following algorithm. So if it's like kind of like near to the center and the and I start like the topic has no movement because it was not close to the so service, and I guess that even is mentioned, of course, the service is used to automatically avoid that like configuration that I needed to do like manually to make like to put like the robot close to one of the walls in order to start like the wall following algorithm that I was using. So the service automatically find like which is the closed wall that are really like in the area that we have, automatically make that approximation, and when it finds like a closed wall, it's gonna return like that that is like okay, it's ready, and then it's gonna start like the wall following topic that we have. That's like the I don't know, the idea of this service that we're using is that automatically
All
give us
right. All right.
the
All
data.
right. I see. I see. Um, all right. Thank you very much for your presentation, Felipe. So what we'll do is we'll do a wrap up here, and then we can finish our conversation on Zoom.
Okay.
All right. So this was Felipe's presentation. We encourage anyone who is willing to take one of the courses that we offer certification on to give it a try, and then you can present on what you have learned. Show us your code base working on a real robot, and until next time, keep pushing your ROS learning. Bye bye.